Good morning, students. In previous session, we have discussed the vehicle on a level road and banging on tracks. And I believe that you all did your homework, example 3.24 and 3.25. Today, we are going to discuss a new topic that is related to our centripetal force. So the new topic is centrifugal force. You see, already we have discussed the centripetal force. Now we are going to discuss centrifugal force, which is around us. You see, already I told centripetal force means there is a force which is acting inward. There is a force which is acting inward. Always there is a force which is acting inward to the center of a circle. Whenever an object which is moving in circular motion, there is an inward force which is acting towards its center. That is what the centripetal force is. Now the centrifugal force means what? You see, assume that in some of the laboratory you can see, laboratory means diagnostic center, the laboratory where our blood and urine sample all it was tabulated, and there we can see the instrument used. Some instrument you can see the test tube they are keeping inside a tube. When it rotates, you can see all these tube, maybe in one machine consisting of more than 20 tubes. So at the same time they will keep 20 sample inside this tube. So you can see that it will rotate very fast. When it rotates fast, you can see all the tube. Before rotating, all the tube was in this position, vertical position. But when rotating very fast, we can see all the tube raised up, and we can see all together it is rotated in this position. So why this is happening? Why this is happening? Sometimes, another example, very good example I will tell you. We are traveling, we experienced this. When we travel on the car or bus or something, suddenly the driver turns the vehicle on a circular road. Suddenly he is going very fast, he didn't see the circular road from far, so suddenly he turns the vehicle. What will happen to us? When we are sitting or standing, we feel an outward force like this. That's what it is saying. It is dangerous to travel on footboard. Never travel on footboard. It is very highly dangerous for you. So this is the reason. There is an outward force. So when this bus, suppose you are standing on the footboard. You are standing on the footboard in the bus. When the vehicle, when that bus rotate in a circular road, suddenly if they are rotating, you will be pushed outward. You will be pushed outward, so there is a chance to fall from the bus. That's the reason they are saying why you should not stand on the footboard on the bus. The force which is acting is centrifugal force. The force which is acting outward from the axis of rotation or from the center of circle. So these forces, this centripetal force, all the circular motion, these forces, centripetal force, centrifugal force, we can analyze from inertial frame and non-inertial frame. You know this thing, inertial frame means what? Just we also experienced that sometimes when we are sitting inside the train, nearby platform we can see another train is there. Maybe sometimes that train will move, but we will feel that where we are sitting, the train is moving. Or you can see, suddenly we will look outside the platform. When we are looking outside the platform, we can see that our train is not moving, our nearby train is moving. This we can identify by the platform. Now the platform is inertial frame. That is the inertial frame for us. The same thing, sometimes we are passing, we know that when we are moving in the bus or train, we are going forward. Sometimes we can see that opposite another bus which is coming at the same speed. So that time also we will feel that that bus is going very faster than us. But when we are looking outside means what? We can consider our nature as the inertial frame. Suddenly when we are looking outside, we can feel that, we will feel that, yeah, it's not going very fast, it is same as our speed only. This all we are considering an inertial frame. In linear motion, we can use these inertial frames to analyze the motion. And non-inertial frame or rotating frame. Suppose one best example you can see. Sometimes when we are traveling in the train, we can see we are keeping the object on the small table which is given on the train. Suddenly the train starts. We feel that the object which is staying at rest, also moving. Without any force, we feel that the object which is at rest start to move. Now we cannot consider this object with an inertial frame, that train. Now, because the train is accelerating, so we can consider this as a non-inertial frame, or we can tell a rotating frame. Okay, this is what inertial frame and non-inertial frame difference. And this thing also, the centrifugal force, which can be analyzed by rotating frame or non-inertial frame. So, you see, we can consider a whirling motion of a stone. You are tying a stone in a rope and rotating. When you are rotating the stone very fast, we know that the tension in the string, we are using the string to rotate the stone, the tension in the string providing the centripetal force m omega square r minus m omega square r. In the meantime, in the same time, there must be an opposite force. This is centripetal force minus m omega square r. There must be an opposite plus m omega square r, which is acting outward. This minus m omega square r centripetal force, which is acting from the stone through the string to inward. This centripetal force is provided by our tension in the string. So there must be, to balance that, there must be an outward force which is acting outward. And this rotation also, we can analyze the motion by using a rotating frame or a non-inertial. Now also one good example you can see that suppose a rotating platform. You can see in page number 154 rotating disc, rotating platform diagrams 155. Suppose you are staying at the end of the platform. When we are staying at the end of the platform, we feel that it is rotating. The platform is rotating. You are standing at the end of the platform. So, when it rotates, you will feel an outward force. So, you may fall from that platform. So that the platform is constructed little at the end, little bend. So, if you are standing here also, you will not fall outward. You may fall inward only. That is what some platform, rotating platform you can see, which is at the end is constructed what curve shape. To avoid falling due to the centrifugal force. So that's what again remember the centrifugal force means what it is highly dangerous when you are standing near the door or standing near the door in a traveling in bus or train, because there is a force. What is this force? You see, centripetal force which is acting, which is arising from a gravitational force, tension in the string, and the frictional force. But this force, this centrifugal force, which is not rising from all these forces like gravitational force, frictional force, and any other force. It is just a pseudo force. It is just a what? Pseudo force. Pseudo. It is just a pseudo force. You can say pseudo force means what? Just an imaginary force. Just an imaginary force. It is not a real force, but it is a force which is not real. It is a pseudo force. That is what? But it has a real effect. That I will explain later. It is a pseudo force. This centrifugal force means what? Just a pseudo force which is acting outward during this circular motion. Now next is one of the important, very important question in this unit. Similarities and difference between centripetal force and centrifugal force. It is one of the very important 5-mark question in this unit. So you must learn today itself. You have to learn. You can see in page number 156, table 3.4. You must learn this question. It is very simple and easily you can get a 5 mark. So you see the difference here. The first difference is centripetal force. It is a real force which is exerted on the body by the external agencies like gravitational force, tension force, normal force, etc. So before we know that centripetal force is provided by who? Gravitational force, frictional force, tension in the string. So this is what centripetal force is exerted on the body from the agency. What agency? External agencies like gravitational force, frictional force. This gravitational force is providing centripetal force. Frictional force is providing centripetal force. Normal force is providing centripetal force. And Here, centrifugal. It is a pseudo force or fictitious force which cannot arise from gravitational force, tension from the string, or normal force, etc. So, centripetal force is provided by gravitational force or this frictional force, but centrifugal force is not arising from all this. It is just an imaginary force. It is just a pseudo force, a fictitious force. Fictitious or pseudo force means just an imaginary force. That is what first difference, and the second difference is act in both inertial and non-inertial frame. So we can analyze this motion with what? Both the inertial frame and the non-inertial frame. If you are saying an example, a vehicle which is moving on a road, circular road, we can analyze the motion with the road. We can consider the road as inertial frame. The motion, we can analyze the motion. So that is what this force act in both inertial and the non-inertial frame. But the centrifugal force act only in what? Rotating frame, because it is accelerating. Now the third one is the third difference. It acts towards the axis of rotation or the center of the circle in circular motion. Before also I told centripetal force means what? Circle is there which is acting towards the center of the circle through its axis of rotation. During the whirling motion of a stone, there is an inward force which is acting what? Towards this axis of rotation. This is the axis of rotation. This is what the V square by we can write. And here, what? It acts outwards from the axis of rotation or radially outward from the center of circular motion. So centrifugal force means, centripetal means acting inward, centrifugal means what? Which is acting outward. Which is acting what? Outward. So here, so this is what the third difference, act only in rotating frame. It acts outward from the axis of. Act only in rotating frame means what? I'll tell you one example, just example. This whirling motion, the same whirling motion, sometimes we feel that the stone is at rest. Sometimes we feel that you take and check. Take a stone and tie it in a string, just rotate it. When we rotate, sometimes we feel that the stone is at rest because what? It is, we are considering, we are analyzing this by using a non-inertial frame, rotating frame. This one. So, that is what the act only in rotating frame. Then it acts towards what? Outward. Centripetal means inward force, centrifugal means outward force. The same formula. And the next difference is real force and has real effect. Origin of centripetal force is interaction. That is another one. Real force and real effect. Centripetal force is arising from gravitational force and it is a real force. And we have the real effect also. Real effect means what? You are sitting and traveling in the car. If there is no centripetal force, enough centripetal force, if you are turning the circular road, your car will get skipped. That is what the real effect. Real force, real effect. Here, pseudo force, but it has real effect. Pseudo force, but it has real effect means what? Just an imaginary force. What? Real effect. You see, you are standing on the footboard when the bus is traveling. Suddenly the bus goes downward. We know that we all push outward. Real effect. Real effect. But what? It is a pseudo force. Just a pseudo force. Imaginary force only. Imaginary force only. But effect is strong. In car or bus or where, anywhere you are traveling, suddenly it changes direction. You push outward. That is pseudo force. But real effect. Next one is origin of centripetal force is interaction between two objects. Centrifugal force is inertia. It does not arise from interaction. Centripetal force is arising due to the interaction between what? Interaction between two objects. During the motion of car, when it is moving, when a car is moving in a circular road, their tire and rod interact with each other. So frictional force is there. This frictional force providing what? Centripetal force. That is what this centripetal force is arising due to the interaction between two objects. And here, origin of centrifugal force is inertia. It is not arising from interaction. That is what you are standing on the bus. You are standing on the bus. When the bus stands suddenly, you are going outside. It is what property? Inertia property. Inertia property means what? Our body continue to its state of rest or uniform motion. So, you are standing at rest. Suddenly when the bus stands, your direction is going outward. So, here what property? Inertia. That is what origin of centrifugal force is what? Inertia. And the next one is in inertial frame, centripetal force has to be included when free body diagrams are diagrammed. When you are drawing the free body diagram, for example, you are drawing a car. You are drawing a car which is moving. When you are drawing the free body diagram, you can draw what? Upward force, normal force, downward force, gravitational force, mg. But centripetal force, Fs. Like this, when you are drawing the free body diagram, you can include what? Centripetal force. But in inertial frame, the object inertial frame motion appears as centrifugal force in rotating frame. In inertial frame, no centrifugal force. But when you are drawing the free body diagram, centrifugal force cannot be included. But here we can include. In inertial frame, what? While drawing the free body diagram, centripetal force can be included, but centrifugal force cannot be included. No centrifugal force. And in rotating frame means you can include both the centripetal force or centrifugal force when you are drawing the free body diagram. So suppose you are drawing the wheeling motion of a stone. There you can include in free body diagram, you can include centripetal force as well as what? Centrifugal force. So my dear students, this is the last topic in our child unit talk. It is very important question. You can see page number 162, book back questions. In that long answer question, question number 1, question number 2, question number 3, question number 4 and question number 6. Question number 6 is this question: explain the similarities and differences of centripetal and centrifugal force in page number, you can see page number 156, table 3.4. All of you mark and study. And question number 1, that is also one of the very important question. Frequently asking these 2 questions only, so you can study and practice the example under this session. Mark all the short answer question and the long answer question. You can see all question number 1, short answer question, page number 106, 107. It is a 3-mark question. Newton's second law, page number 109. Define 1 Newton, page number 109. Impulse, page number 133. Using free body diagram, show that it is easy to pull an object or push. Page number 140, it is very important, the 3-mark question. Various types of friction, you can write about the definition for static friction and kinetic friction. Then pseudo force, you can write this definition from page number 153. Then state the empirical formula, page number 137 and 139, it is there. You can mark it. Equation number 3.27 and 3.28. These 2 equations, that is empirical law. And Newton's third law, you all know that page number, you can mark and study Newton's third law. And inertial frame, page number 108. Then 11th question, under what condition will a car skid on a circular road? Page number 151. Yesterday I have taught you the conditions for the vehicle on a circular road. What the condition to skid or safe turn in page number 151. And long answer question, as it is given in the textbook, you can study. So see you all. Bye bye. Thank you.